All right, we just learned how to factor trinomials using the AC method, and I want to take a moment to show you why the AC method actually works. And to do that, I want to look at a few examples of polynomials that can be factored by grouping. So let's take a look at 2x squared plus 6x plus 1x plus 3, and 2x squared plus 14x plus 5x plus 35, and let's do one more, 3x squared plus 2x plus 3x plus 2. All three of these are examples of polynomials that can be factored using grouping. If you want to verify that, you can pause the video and you can go through the process of grouping. But for right now, I want to focus on an interesting pattern that comes up involving the coefficients. So let's take a look at the coefficients here. Each one of these has 4 coefficients, and there's an interesting pattern that comes up when we look at the coefficients in any one of these problems. Let's take a look at the first one. The coefficients are 2, 6, 1, and 3. And I want to point out that these coefficients are proportional to each other. And the same is true with the other ones. We've got 2, 14, 5, and 35. These coefficients are also proportional. 2/14 equals 5/35. And the same is true here, though it might seem even more obvious. 3, 2, 3, and 2. In all of these situations, the coefficients are proportional. And the reason we need them to be proportional is so that when we pull out the GCFs in each of the groups, the leftovers end up being the same. This is just something that needs to happen whenever we're factoring by grouping. So, if we're looking at a polynomial like ax squared plus mx plus nx plus c, then we know the coefficients have to be proportional, so a over m equals n over c. However, when we cross multiply, we end up with m times n equals a times c. So in this case, we can see that these numbers, m and n, have a product equal to ac. And because this is supposed to come from ax squared plus bx plus c, we know that m plus n has to equal b, because we need these two terms to be equivalent to bx. So we know that the sum of these two numbers has to be b. And in fact, this is exactly what the AC method says. It says that we're looking for two numbers that have a product of AC and a sum of b. And the reason we're doing all of this is so that when we split up that bx into mx plus nx, we end up with coefficients that are proportional, which is necessary to be able to finish the problem by grouping. So this is some of the behind-the-scenes stuff that goes into making the AC method work. It's nothing that you need to know to use the AC method, but I wanted to explain it in case any of you were curious.